Section 12.1, we're looking at one-way analysis of variance. Analysis of variance can be also abbreviated as ANOVA when an F-test is used to test a hypothesis concerning the means of 3 or more populations. The assumptions: populations from which the samples are obtained must be normally or approximately normally distributed. Samples must be independent of one another. The variances of the populations must be equal. The samples must be simple random samples, one from each population. Even though we are comparing 3 or more means, variances are used in this F-test instead of means. 2 different estimates of the population variance are made. The first one is known as the between group variance estimate, and that finds the variance of the means. And then the within group variance estimate, we compute the variance using all the data. It's not affected by the differences in the means. If there's no difference in the means, the between and within group variance estimates will be approximately equal. Your F-test value will be approximately 1, and the null hypothesis will not be rejected. If the means differ significantly, the between group variance will be much larger than the within group variance. Your F-test value will be significantly greater than 1, and as a result, the null hypothesis would be rejected. Shown below, we have 3 random samples of times and minutes that commuters are stuck in traffic for 3 different cities. At the 0.05 level of significance, is there a difference in the mean times among the 3 cities? Our first step will be to state the hypotheses. The null hypothesis will always show that the means are equal. Notice we see mu, that's our population mean, and then little subscripts just denote the 3 different populations. If you have more than 3, you'll see a mu sub 4, a mu sub 5, however many you need. And then your alternative hypothesis will always state at least one mean is different from the others. To find your critical value, your degrees of freedom numerator is going to be k minus 1. K is the number of groups you have, or the number of different populations. Degrees of freedom denominator, capital N minus k. That capital N is the sum of the sample sizes. Always going to be a right-tailed test. And we need to use Table H, pages 792 to 796. So let's go ahead, let's figure out our degrees of freedom for the numerator and denominator. For the denominator, we have k minus 1. We have 3 different populations. Each city would be a population. So we have 3 minus 1, which is 2. The degrees of freedom then for the denominator, we have our capital N, which is the sum of the sample sizes. Be very careful, you're not adding up the samples themselves, you're just totaling up how many samples, how many people were sampled. So we have a total of 15 data values. The sample size for each city was 5. So our total is 15 minus the number of groups, which is 3. So degrees of freedom for the denominator will be 12. Our alpha value is at 0.05, so let's go to Table H. We have to make sure we're on the page for alpha 0.05. Degrees of freedom denominator is in the left-hand column. That's going to be at 12. Degrees of freedom numerator is in the top row. So 12 and 2, 3.89 should be our critical value. Let's go ahead and jot that down. Next, we need to compute our test value. In order to do that, we need to find the mean and the variance of each sample, and we can let the calculator do that for us. What you want to do is enter all your data values into a list. So each list for each city. Once you have those entered in, you can go Stat, Calc, and do the one variable stats. you want to make sure you do it for each list. If you have the TI-83s, you'll have one var stats on your screen, and then you do have to type in the list that you need after that, otherwise it'll continue to find it for list 1. There's our X bar, there's our mean for our first city, and then you're given the standard deviation. Remember, this is a sample, so we want to use the S. This is a standard deviation. We have to square that in order to get our variance. So just keep that in mind. This is standard deviation. We need variance. So I'm going to go ahead and jot those down for the 3 cities. You can do that in your calculator also. If you want to pause here and then get those in your calculator, you can. And I just use little subscripts to denote the difference between those 3 cities. And again, I use my calculator to find all of these. Just do the one variable stats for each list. If you want to try this yourself, you can pause the video here. The next thing we need to do is find the grand mean. That means we add up all of our x values. So you add up every single data value in that table, and you get that sum. And that sum comes out to be, if you add up all the data values, you get 839. The capital N, remember, that's the sum of all of our sample sizes, and we had 15 total values. So our grand mean comes out to be roughly 55.93. Now we're going to find the between group variance. We see our capital sigma, so we do have a summation. Little subscript i's, those are just representing each of these little subscripts we have for our 3 different samples. So we take the sample size for our first city, which was 5. Then the mean for our first sample, which was 60.6, minus the grand mean, quantity squared. Lowercase k is our number of groups, which was 3, minus 1. For our next sample, we had sample size of 5, a mean of 54.4, the grand mean 55.93, and again, number of groups, minus 1. Our last city, we had a sample size of 5, a mean of 52.8, a grand mean of 55.93, and again, number of groups, minus 1. Now, since all of these have the same denominator of 2, you could add together all the numerators and then just divide everything by 2. If you do the computation, our between group variance estimate is about 84.87. The numerator of the sum, so when you add all those numerators together, it's called the sum of the squares between groups. And we want to go ahead and make note of that here. And then your between group variance estimate is also referred to as a mean square. So it'd be mean square, and then the B would stand for the between group variance. Now we need to find the within group variance. Again, we see a summation, capital sigma. So we take our sample size for the first sample, minus 1, times the standard deviation from that, the variance from that first sample, which was 4.28, plus sample size of the second sample, minus 1, times the variance of that second sample, which was 5.29, and then for our third one, sample size minus 1, times the variance for that last sample, 6.71. Now in the denominator, you have to note we do have that capital sigma, so for each sample, we do sample size minus 1 for all 3 samples. Now your sample sizes will not always be equal. This example just happens to be that they are all 5. So if we go through, we do our computation, we get a within group variance of 5.43. The numerator is called the sum of squares within groups, or the sum of squares for the error, and our numerator was 65.12. The within group variance estimate is also referred to as a mean square, and we see a mean square, and then the W for the subscript is for the within group. Next, we find our F-test value, so we take our between group variance that we had of 84.87 and divide by our within group variance of 5.43. Again, these little squares, they're just there to symbolize the variance. We do not have to square these values. So our F-test value, 15.63. Time for us to make our decision. We can draw this out if you'd like. F distribution, this one's always going to be a right-tailed test. The critical value was at 3.89. So then our test value of 15.63 is in that critical region, that rejection region. So we reject the null. And then we summarize. We can say there is enough evidence to support the claim that there is a difference in the mean times among the three cities. And that is what we were trying to show in the question. After an analysis of variance is complete, we typically fill out a summary table. So our sum of squares for our between is 169.7335. For the within, it was 65.12. Degrees of freedom for the between is just k minus 1. So in this case, that would be 2. Degrees of freedom for the within, which was the denominator, is capital N minus k. So we have 12. We do have a total row. We add together the sum of squares. We get 234.8535. The sum for the degrees of freedom was 14. Our mean square for the between was 84.87. For the within was 5.43. Our F-test value is 15.63.